Okay, so for number 1, you were given a domain. You had to find the range. So you needed to put each of these in and find each of the y values. You could have done this a couple different ways. Algebraically, or in Desmos, say your calculator. If you put this into Desmos, make your table, and find those, it'll give you your y value. Same thing on your calculator. Algebraically, it would look something like this. Y equals 2 times negative 3 plus 4. Y equals 2 times negative 2 plus 4. Y equals 2 times 0 plus 4. And y equals 2 times 3 plus 4. And then you would simplify all of that and figure out what it is. 2 times 3 is 6. 6 plus 4 is 10. 2 times 0 is 0. Plus 4 is just 4. 2 times negative 2 is negative 4. Plus 4 is 0. And 2 times negative 3 is negative 6. Plus 4 is negative 2. And then you would need to list them in curly brackets. This is the domain is. That would be from least to greatest, negative 2, 0, 4, 10.
I have a question about historic history. Are we taking that next
I'm gonna explain all of that after we go over this. For number 2, we need to figure out which of these are functions and which are not. We could use the vertical line test. If it goes through more than one point, then it is not a function. Is the first one a function? No. Is the second one? Yes. Is the third? Yes. And then number 3, we need to find the slope. So remember, that's your y2 minus y1 over x2 minus x1. So we would have negative 2 minus 3 over negative 5 minus 2, or negative 5 over negative 7, which would simplify to just positive 5 over 7. Questions on those 3? On the back, we need to find the x and y intercepts. So if we were finding the y-intercept, we would need to put 0 in for x and solve for y. So this would give us 0. Then we could divide both sides by negative 6. So that ordered pair would be 0, 2. Then we could do the same thing to find our x-intercept. If you know that the term you put 0 in is going to disappear, you could skip to this step. So I know I'm putting 0 into my y term, it's going to disappear. So I could just start here. You could still do this process, but you don't have to. So that ordered pair would be negative 4, 0. Questions on that? Number 4, ignore this 5. That's why that R was there. I'm going to go to the R actual 5. Yes.
Why substitution finds the same answer
so that may have been just luck, because what you found was, in order to use substitution, you have to have 2 different equations. And you only have one. So you substitute it into each other, and that usually does not work. Okay, so ignore this one.
Did we learn that like last year or something?
Literal equations we haven't actually talked about. To some extent we have, but have not. When we're solving this for y or solving this for x, that's kind of literal equations, what the other one was. But we haven't done that with other variables except x and y. So for this one, you needed to solve this for y, so add 3x to the other side. change the order and divide everything by negative. We have y equals negative x minus 3. Questions on that one? Alright, before we get into what we're going to do today, there's a couple things that I need to talk to you about, so make sure you're paying attention. I need everyone's attention. Okay. Close your laptop so I know that you all are paying attention. Theo. Close your laptop. Thank you. Alright. First, you're supposed to have access to all 3 tests. It was open for the wrong day. So if you did not take the word problems test, you'll have to come before or after school to get that done as soon as possible. So my apologies for that, but we don't have time to do a whole nother class, so you guys can take that in class. Questions about that before we talk about something else? Okay. How many of you have already heard something about a STAR assessment for English? Okay, if you have not heard that, that conversation is coming. It'll sound something similar to this. Okay. So the county is doing an assessment in English and math to see where you are right now, what knowledge you have right now, and then it's like a growth thing. So you're going to take it again towards the end of the year to see how much you've grown from now to then. And we're going to take that next class. It is a computer adaptive test. I don't know if this is the same for English, but as you start to answer questions more and more correctly, it tends to get harder. So there will be questions that you may not know the answers to, and that's okay. And then also the opposite is true. As you get questions wrong, it will drop back to the level it assumes that you would know. They say that there should be about 34 questions. It could be 35, 36. It is timed in a sense. Each question is timed, but not the entire test. So you have 3 minutes per question. And at the end of each 3 minutes, like 15 seconds towards the end, a timer should pop up to tell you you need to choose a question, choose an answer. Otherwise, it'll count as a missed question, and it'll go away. Say that again.
Are we going to know like what we get after the test?
I don't know immediately after. I think I get those scores. I don't know when exactly.
Is it going to have like geometry, algebra too, or just algebra?
I don't know specifically. They said it's not a specific math content. I've heard that, like in another algebra class, they finished and didn't see any like geometry stuff. So they say it's from 7th to 12th grade math, but I think that's just whatever 7th grade math is to algebra 2. So there may be things that you don't know, and there may be things that you do know. What other questions do you have?
So we're going to take ours on Monday?
On Monday, yes. So make sure you have your laptops on Monday. I'll send out an announcement on Sunday to remind you. What other questions do you have? Bella. Say it again. No. So it has a built-in calculator for questions it deemed a calculator necessary. You guys will not be using calculators for that. Michaela.
Is it a grade or just like?
It's data for the county.
So like, what's going to happen if you do good or bad?
It's just information for the state.
Yeah, so if you do really well, that means you know more than this class is probably going to teach you. And when you take it again / finish the second part towards the end of the year, you're going to start where you stopped level-wise, and it could get harder then. Is really all I know about it. If you do bad, that means you need to learn more from now until then. Any other questions on that? If you think of another question you have later, feel free to ask. What was I going to say? Oh, your calendar does not have that on it because we were literally just told this last week, and I had already made those. Your calendar is also not accurate for this other reason. So the algebra classes, you guys included, are going to be taking an SOL pretest just to see where you are, what you remember, what you know, and there's things that we obviously haven't gone over, so there'll be things that you don't know as well. Just to see what we need to focus more on before the SOL in May. Okay, I don't know that answer just yet. Sometime in the next couple of weeks, though.
Well, yes. Our actual test for this unit that we're going into, or you not know?
Say that one more time.
Do you know like when we're going to have our actual unit test for this unit?
That depends on when the pretest is, because if it's within the dates that are here, so one, this is already messed up one day because of the STAR assessment. And then if the pretest also falls within this, it'll be pushed back another day. That's why I haven't put it on the board yet. Whatever Canvas says right now is probably not accurate, and I need to change it and update it again. There are questions on that. Alright. So the unit we're going to start today is on inequalities. Some of this stuff you will have seen before. It will look familiar. You'll know how to do. Some of this stuff you won't have seen before. It won't be familiar, or you won't know how to do. That's okay with both of those. So you should have notes that look like this.
It's like greater than
Say that again.
it's greater than
Yes.
Oh, wait, probably.
Go for it. Hold on a second.
Yeah.
Okay. So the problems that have like stars or different numbers or this, you can ignore this. All of the lessons that I print out are also on your formative as well. I don't think they're assigned to you directly, but if you go into your Canvas, they're there. So that's what these numbers are for. But ignore that. Alright, so for this first part, we need to use an open circle for strictly less than or strictly greater than signs, and a closed circle for less than or equal to or greater than or equal to. So I'm going to do a couple of these just to get our memory back into this part. This part I feel like you've seen or done before. So for number one, if I had to, let's say I already solved this and this is the answer I got, x is less than 3. Would this be an open or a closed circle? Open at 3. Going to the left or going to the right? Going to the left. For the most part. So if it's in this form, variable on the left, number on the right, then whichever direction the arrow points would be the direction that you draw the line. Yes. But if I were to change this, and let's say you solved it and you got the opposite way. Read like this. The arrow is now not pointing the way you want to go, but if you were to read this backwards, and not left to right or right to left, x is still less than 3, so it would still go to the left. For number 3, would that be open or closed? Closed at 7. Going to the right or to the left? To the right. You can draw a circle and fill it in. Questions on those two before we do some other examples?
Why would the circles be closed on number 2?
Because this one has this equal to symbol underneath the
So
sign.
everything that has the equal to
Is closed. Yep. For number 5, now we have an inequality drawn and we need to write the inequality for it. We know it's open, so it has to be strictly less than or strictly greater than. It's pointing to the left. Would it be less than or greater than? Less than. So x is less than -2. If you're not sure if it's less than or greater than, pick some of the numbers that fall on the arrow. -6, is that less than or is that greater than -2? It's less than, so it'd be less than. For number 7, we know this is at 0. What would our symbol be? Less than or equal to. Right. Questions on that? Now we're going to actually get into the solving aspect of this. First, you must flip or switch the inequality symbol when you multiply or divide by a negative number. So I'm going to give you a couple examples of what that means. Right, so let's say we're at the very last step of solving something and we get something like -3x is less than 3. Yeah, so you're going to completely flip the direction that it's pointing. So if I were to divide by a negative here, magically this changes direction.
So you just have to divide and then switch it?
Yes, if you divide by a negative, not just when you divide at all. However, if I had something like 3x is less than -3, and I divide both sides by 3, that would not change the sign because I didn't actually divide by a negative. There was a negative, but I didn't divide by a negative. So when I actually divide by a negative, the sign changes. But if there just happens to be a negative on the other side, the sign does not change.
So only divided by what becomes on the left side?
It also depends on where your variable is.
So which one's right?
Right now, these are both right. We didn't change the sign here, so this is right. Had we changed the sign, this would be wrong.
Oh, 3x. 3x. What's on it?
If the 3x was negative. If the number by x is negative, and then you divide it, that's when you change the sign. Now, if you have an example where you're multiplying, so that would be something like, I'm just making these up. I would need to multiply both sides by -6 to get it out of the denominator. And And because I multiplied both sides by -6, my sign would change directions. But if I had something similar where it's not negative, I didn't mean to make these both negative. That's all right. It'll make more sense when we actually solve it. My brain is doing too much work. So when you actually multiply or actually divide by a negative, the sign changes. If you don't, it doesn't. So let's actually do an example so you see how that works. So when we solve these, think about your inequality symbol like an equals. Think about it like that way. Don't actually change it to an equals because you may forget and then not change it back, and then maybe you're supposed to flip the sign, and then now you don't know what the sign's supposed to be. Don't actually change it to an equal sign, but pretend it is. That way when you solve it, you know how to solve an equation. This is similar. So here, how would I start solving this?
I think you subtract 2.
Yes. Subtract 2 on both sides, just like you would in equation. And then divide both sides by 30. Would the sign change? No, because you do not divide by a negative. You have a blank number line, so you can fill out this number line. I usually put whatever this is in the middle, and then count out from there. So this would be -1, 0, 1, -3, -4, and -5.
Do you have to put all the numbers?
Yes. Have to put all the numbers? Does it have to be exactly like mine? No. If you want to put -2 closer to the edge, that's fine. Would this be open or closed? Open. Going to the right or to the left?
Right.
This will go to the left.
Oh.
Do you have any questions on how we solved that one so far?
I'm just gonna put that.
Kind of, but not Savannah. I should kind of be okay with that. If he's not back in the next 5 minutes. Right. For number 10, how would we start solving this?
Subtract.
So you could do one of two things. You could subtract 2 on both sides. You could multiply 6 to everything to get it out of fraction form. Both of those would be correct. It doesn't matter which one.
Isn't it if you subtract 2 first, it would get like
It wouldn't really matter. If you multiply everything by 6, you no longer have a fraction to deal with. You would just have, you created an extra step for yourself is all. So here, we would multiply both sides by 6. We have x is, would our sign change? No. Sometimes these numbers get big, and that's okay. -17, -16, -15, -19, -20, and 21. This would be an open circle, but to the right. Questions on that one? We're not going to do every single problem. I just wanted to make sure that we had these two. On the next page. Now, in the past, we talked about set builder notation. That was like x is, or -3 is less than or equal to x, which is less than or equal to some number. or with the curly brackets, all of those things. Now we're going to be using interval notation. Because if you're writing, paying attention. Okay. So with interval notation, we have to relate our not included or our open circles to be parentheses, and our included closed circles to be square brackets, not curly, but square. And then anytime we go to negative or positive infinity, we use parentheses.
Yeah, that'd be good. We'll go over that other thing.
So for number 1, how would we start solving this? We could multiply. We could also divide. So I could divide both of these by 4 because 24 is divisible by 4. Either way, you would get the same answer. But let's distribute. See, just so you know, this bathroom is open again, so that's the bathroom you need to go to. Right, and then continue solving this. So subtract 12 on both sides. And divide. Would my sign change? No. So we could graph this like normal. Open circle at -9, going to the right. But when we do our interval notation, we're looking at this like we would our domain, because these are x values. Where does this start? -9. And -9 is an open circle, so that would be parenthesis -9. Where does this end?
6.
Not at 6, towards infinity. It keeps going off the page to the right towards infinity. So anytime you do infinity or negative infinity, use parentheses. Yes, I'm not. If it goes to the right, it'll be in that format. If it goes to the left, it would be negative infinity first, and then whatever number. If it's included or the circle is closed, then you're going to have a square bracket just at the number, but not at infinity.
For example, you ever have like one regular parentheses and one bracket?
Yeah. Because one's always going to positive or negative infinity. So that's always a parenthesis. And then if it's equal to, that's going to be a square bracket. So let's do 3.
So would it ever be 2 brackets?
No. For this right now. Later, it could be. Later in another lesson, not today. So we would start this off by distributing. Combine your like terms. And start solving. So subtract 8. And divide. So here our signs would not change. I was trying to find an example that was less than and change, but I think this one is less than. Oh, I guess we can do that one. But then it wouldn't be less than over here. It's fine. So this would be a closed circle at -2. Where does this one start? That's where it ends. Negative infinity. It keeps going to the left off the page. So it would start at negative infinity and it stops at -2, but that one would need a square bracket.
The side where it has.
Because you always have to look at it left to right.
Like you're reading a book.
It's pretty much the wrong thing.
Can we repeat your question?
So for negative, did you put
For the, it's a parenthesis, for this one. And then the 2 is a bracket.
why is it in the bracket?
Because the circle is closed. Yes.
Number 2 changes the sign.
So is that right? When you divide it, you mean I don't remember the answer off the top of my head. Okay.
Wait, so you just don't use brackets at all? You don't use brackets to start at all?
No. Anytime you go to positive or negative infinity, it's always parentheses.
So the brackets still have to go.
No.
How do we have to put brackets?
The arrow will
Okay.
be that.
Wait, did you say they don't never start with a square bracket?
Not unless it's going the other way. So if it's going towards positive infinity,
Numbers first.
if the number's first, yes. But if infinity is first, it should not be a bracket. Other questions on that one? Skip to the next page. We're just going to do a couple of these. And then I'll let you try some. Starting with number 5. We have different options. Wow, I didn't mean to throw that. What do we want to move? I mean, not the
On both sides.
add. We would subtract 1 on both sides, but sure. And then we would need to add 2x on both sides to get 8x is less than 8 and divide both sides by 8. So that would be an open circle at 1. Going to the left. What would our interval notation be? Parentheses, negative infinity. 1 with what type of parentheses? Okay, I meant to say this before, but our interval notation, so this is basically our set builder notation. X is less than 1, or our inequality. And our interval notation, these are saying the exact same thing, just in different ways. Let's do one more.
So is it always negative depending on the way the arrow is?
So if it's going to the left, you're going to start with negative infinity. If it's going to the right, you're going to start with your number. Bathroom. And this bathroom is open, so you can use that. Or, I'll say it should be. I just saw custodial, so check it first.
It's always sideways.
Let's do number 10.
Ooh.
Both For 10, we now have to distribute first, so let's take care of that. Now, with this, we are multiplying by negatives on both sides, but separately on both sides. We're not like doing the same thing to both sides, so we would not change our sign immediately. Only if we are multiplying and dividing the same number to both sides do we change the sign. So this would be negative 3x minus 3 minus 2x. The sign stays the same. Negative 4x plus 8 and then minus 2. We could combine our like terms. Negative 5x minus 3 is greater than negative 4x plus 6. What do we want to move first? Plus 3. We have negative 5x is greater than negative 4x plus 9. Add 4x to both sides. We have negative x is greater than 9. Divide both sides by negative 1. Here, our sign would change direction because we divided by a negative. Now, before we graph this, I'm going to go back to this step and show what would happen if you move your variable first. You don't have to write this. You can. Okay. So let's say instead of moving my variable to the left, I moved it to the right.
Oh my gosh, it keeps going.
And then moved my number to the left. These two answers are the same. They're just written differently. Could you change this to this? Yes. When you flip it around, you need to make sure wherever this is pointing to or from stays the same. So here, this is pointing towards the x. So when I flip it around, it needs to still point towards the x so that you get the same thing. You don't have to rewrite it. You can leave it like this. But if you leave it like this, you have to remember to read it backwards, not left to right. So x is less than negative 9, not the other way around. Okay. Right, so that would be an open circle at negative 9. Going to the left. What would our interval notation be? Bella? Yeah. Negative infinity to negative 9 with a parenthesis. Do we have any other questions on how we solve these inequalities? For the next 10 to 15 minutes. Michaela, go ahead.
Will we ever get like a decimal or a fraction for this?
You could. I don't think these have decimals or fractions, but in general you could, yes.
Like in your class?
That I don't know the answer to. Okay. So for the next 10 to 15 minutes, I want you to go back and do each problem that we did not do. So that is numbers 2 and 4, 6 through 9. So I'm going to say the final answer, the direction, it should be graph, whether it's open or closed, and then the interval notation. So for number 2, your answer was x is less than negative 5. So that was an open circle to the left.
What do you mean negative 5?
Because you would divide by negative 2.
Okay.
And, hold on one second. And then your interval notation would be negative infinity to negative 5, both with parentheses.
misleading.
Oh my God. Lily.
What?
I mean, our.
We did 3 together, right?
Yeah, we did 3.
For 4, you should have had x is greater than or equal to 4. It's a closed circle to the right. That would be a square bracket 4 going to infinity with a parenthesis.
We have different now.
How did you get -3? Subtract 8 on both sides. Some of the steps on this aren't shown. It's not my handwriting. Cool.
Yeah, we can't. I don't
Is there a way to do a problem wrong and then get a different answer? Wait, that's the dumbest question
It
I've
happens
ever
sometimes, but the
asked.
answer to that is yes.
Yes, you can do a question wrong, get a different answer.
I feel like that wasn't what you were trying to ask, but it may have been.
It's not the question I was trying to ask.
Can you do it a different way and get the same answer? Is that what you meant?
Yes.
Sometimes. Okay, number 6, x is greater than or equal to -7, closed circle to the right, square bracket, -7 going to infinity with a parenthesis.
Oh my God, that's the dumbest question I've ever asked.
7, x is less than or equal to 6, closed circle to the left. That would be parenthesis, -infinity, 2, 6 with a square bracket. Eight was x is greater than -3, open circle to the right. So both would have parentheses, -3 to infinity. I mean, that's
This is the part where I do math, but it's part that I don't.
At which point did you get lost? So subtract 10 on both sides, you get 24. And then divide both sides by 4. And then for number 9, x is greater than or equal to 11, closed circle to the right, square bracket for 11 to infinity with a parenthesis. Do you have any other questions on these? Okay. Find this. And I'm going to have you guys fill out this part.
Yay, work problem.
Okay, so I'm going to try and give you like an example of each so you know kind of when to use it. So at least would be greater than or equal to. I have at least $5. I could have more than that, but I have 5. I don't have less than that.
I don't even have 5.
I'm blind. I don't have $5 right now.
Gotta say you're a teacher.
That does not mean anything. At most is less than or equal to. I have at most 23 students in this classroom. I don't have more than that. I could have less than that, but I don't have more than that. No more than is like the opposite. So more than is greater than, but no more than is the opposite. So this is also less than or equal to. So it's kind of same example. I have no more than 23 students in this classroom. I could have less, but I don't have more than that. More than is greater than. No less than is the opposite. So, trying to think of a good example. It would be similar to at least.
Is than a word?
No. Yeah.
Such a weird word.
And less than, well, is just less than. So in this case, When you see less than, it's the actual inequality symbol. Unless you see it twice, then it's inequality and subtraction. So don't think subtraction unless you see it twice.
They're putting it less than
It would say something like, whatever the problem is, less than whatever. Less than 3x, 3 times x, whatever. Is less than, it would literally say it twice. But they try to avoid doing that, so it's not confusing. But I have seen 1 or 2 problems like that. So we're just going to do a couple of these problems. Does anyone still need this?
Yeah, just a sec.
This is just one section of the test.
Everything we did today is one section, yes.
Oh, wait, so word problems are in parts?
Yes.
No.
So that's what
No. It's going to be 4.
Wait,
What? Look at your calendar, all of the different lessons.
Wow.
So with this, we need to define our variable, write our inequality, and then solve. 4?
I'm sorry, I'm late.
It's just
So as we read this, I'm going to read it out loud really fast. Keith has $500 in a savings account at the beginning of the summer. He wants to have at least $200 at the end of the summer. He withdraws $25 per week for food, clothing, and movie tickets. How many weeks can Keith withdraw money from his account? Important things. He has $500 at the beginning of summer. He wants at least $200 at the end. He withdraws $25 per week. And we're looking for how many weeks?
What do you want this one?
Say that again.
Why would you want this one?
I mean, he wants to have fun and he needs to eat. They're currently back closed. So,
Plus he can't starve.
So, can't not spend.
We're afraid their house. They have money.
So you can say W is number of weeks. And what inequality word do you see here?
At least.
At least. Which would mean what symbol? Greater than or equal to. So we know that much at least. He wants to have at least $200. So usually whatever your inequality symbol is will go right next to whatever number you need. So at least $200. He could have more than that, but he wants to have at least that much. So now to write the other part. Withdrawals $25 per week. What operation would that be? Subtraction. He's taking money out. Per week, that part would be multiplication. So anytime you see per or for each, you're going to multiply those together. So we have 25 per week. Number of weeks would be W, so 25W. We know we're subtracting, and that's going to be from our 500. So then we could solve that. When we solve this, our sign is going to change direction because we're dividing by a negative. And what number do we get here? 12.
Oh, I didn't know.
So even though we started with at least, we still want him to have at least $200. But he cannot he can't withdraw more than 12 weeks. So we can say no more than 12 weeks.
Isn't there? No. Summer break is 3 months. And each month to 5 weeks.
Michaela?
Can you say at most 12 weeks?
At most 12 weeks.
So technically, he can set for the whole summer.
Yeah.
Unless he wants to spend extra, which probably not.
So he can withdraw for no more than or at most 12 weeks to get at least $200 left at the end of summer. If he withdraws more than 12 weeks, he will have less than what he wants. You have any questions on that one? We're going to do one more. On the back. Maybe number 3. So really quickly, important things. Chris wants to subscribe to a meal subscription service. Each meal costs $15.99 plus a one-time fee or a one-time shipping cost of $9.99. If he can spend no more than $100, how many meals could he buy? So here, number of meals would be our variable. Our inequality word here is what? No more than, which would be less than, what did I say? Is that right? Yes.
No more than.
Because it's opposite, sorry, I like trying. Okay, so no more than $100, he cannot spend more than what he has. It actually tells us that we are going to add. And we know each meal costs. I'm going to highlight that. Yes. Under the result. Subtract $9.99. And divide. What do you get?
$5.63.
Are you looking for cost though? What are we looking for? Number of meals. So number of meals can't be a decimal, so we need to round. Now the question is, did we round up or did we round down? In normal math rules, yes, we would round up. But if we rounded up, would we go over our limit?
Yes, you can make it.
Yes. Right. We can't make up the meal that's not there. We have to round down. So we could do 5. He could do 5 meals and have a little bit of money left over. He cannot do 6 meals. He would not have enough money, and there wouldn't be enough meal. You guys have 5 minutes left. I want you to try those 3 problems, and then I'll let you grab your phones.
I hope it's correct.
Number 2. I'm just gonna say the answer. If we need if we have questions on anything else, we can talk about that. So no more than 12.69 was the actual decimal, or 12.7 miles.
Either one.
This is. I'd have to double check it. Do exact for now until I check it. The 0.7 could throw her money off.
Well, I put 6.
Okay. For number 4, at least 950 bags. And for number 5, less than 40 degrees. So you do have 2 delta mass and 2 conconomies that are due next class, so Monday. If you have questions on any of those, want to go through any of those, come see me after school today. If you need to finish your tests, you can come see me after school today or tomorrow morning or Monday morning or Monday after school. Remember to bring your laptops on Monday for the summer assessment.